Hello, Geometry. This is Miss Wiley, and these are notes for section 5.1. You're going to want to go to your student journal on page 125 to access the same pages that I am going on. The other thing is we will also be using Desmos, so have your computer or the phone app nearby. So first thing I want to go over are some of the definitions. We're going to skip corollary to a theorem, and we're going to talk about interior angles and exterior angles of a triangle. This chapter is all about congruent triangles. So you'll see a lot of information about different types of triangles down below. Okay, so the interior angles of a triangle are what we call the original angles. Okay, when you look at a triangle and you look inside the triangle, those are your inside or interior angles, as they call them. The exterior angles are a little bit different. I'll show you a picture of that in just a moment. But what exterior angles do is they make a linear pair with an interior angle. Okay, so with an interior angle. Okay, and it's basically what happens when you have a triangle. I'm just going to draw a triangle here. Okay, if we had angles like angle 1, angle 2, angle 3, those are interior angles. So I'll write that up here. So angle 1, angle 2, angle 3. An exterior angle is going to occur if I take a side of that triangle and I extend it like that. It's going to create an angle here on the outside. I'll call it angle 4. Okay, that would be what we call an exterior angle. So an exterior angle is going to be something like angle 4. And if you notice, the measure of angle 1 plus the measure of angle 4 creates a line, which is 180 degrees, which is what we call a linear pair. That's just one example. Now I could create more exterior angles by extending the other sides of the triangle like so, right? But that gives you at least one example. Down below, we have two ways to classify a triangle. We can classify a triangle by its sides, and we can classify a triangle by its angles. These are names that you have already seen before or heard of before. We're just defining them a little bit more right now. So a scalene triangle, as you see here, is a triangle that has no congruent sides. So it's very important that you see that has no congruent sides. So notice there are no congruency marks on here because none of them would be the same. If you wanted to put congruency marks, it would be like this, where none of them are the same. Okay? An isosceles triangle is a triangle that has two congruent sides. You can see that that's marked here for you. An equilateral triangle is a triangle that has all the sides congruent. So you can see that they put two tick marks on each side of that triangle, stating that all the sides are the same length. Classifying a triangle by its angles is looking at the interior angles. So when we're looking here, we're looking at the interior angles. We should be familiar with most of these. An acute triangle has all the angles being acute. Remember, acute means that the measure is less than 90 degrees. A right triangle is going to mean that you have one right angle. Remember that a right angle is 90 degrees. And a right angle will be marked with a little square in the corner. Never assume a right angle. Obtuse angle. An obtuse angle is going to have one angle that's obtuse. You can see that right here, that's going to be your obtuse angle. An obtuse angle means that it's greater than 90. Okay. And then we have an equilateral triangle. An equilateral triangle means that all three angles are congruent, and they have those arc marks there to show you that they are congruent. Now, if one thing that we are going to learn about a triangle is on the next page. Go to page 126. And I will do an example of classifying triangles in just a moment. On page 126, okay, one thing I want you guys to know is there's a bunch of theorems here. You don't need to worry about the theorem number. Let's just concentrate on the theorem name and what that theorem is. You do not need to memorize these theorems. You need to remember that they exist, when to use them, how to use them. So you want to, like on this page, you may want to bookmark it because it has lots of important information on it. The triangle sum theorem is a theorem that you might already know, and it's the idea that the sum of the measures of the interior angles of a triangle is 180 degrees. So if we looked inside this triangle here, it means that if I took each one of these angle measurements and added them together, I would get 180 degrees. Okay, so let's go back to that equal angular triangle and think about if all three of the angles have to be the same and they all have to add up to 180, what would be the measure of each angle? We would take the total of 180 degrees divided by 3, and they would have to each be 60 degrees. The measure of each angle is going to be 60 degrees because 60 plus 60 plus 60 is 180. So that's good, useful information to know about triangles. All right, I'll go over the other two theorems in just a moment. Let's go to page 127. And let's talk about classifying these triangles by its sides. Now, you don't have a way of measuring the angles on paper. I believe in Big Ideas, they give you a protractor. So I'm just going to talk about these triangles as if we have measured them already. Okay, so in number 1, okay, we're going to classify it by its sides and by its angles. That means you're going to have 2 answers for each problem. In number 1, I will tell you that you have one obtuse angle here. And if you notice the side lengths here, none of the side lengths have congruency marks like number 3. So because of that, since I have no congruency marks, I cannot assume that any of them are the same. Since none of them are congruent, I know classifying by its sides, this is going to be scalene. Okay. Then I know, as I told you, that angle Q, I'm going to tell you that that is obtuse. I don't have a way of using a protractor in this program, but I will tell you when I did it on paper, it was definitely obtuse. It's the only obtuse angle in this triangle, right? So if I have one obtuse angle, that means that you're going to have what we call an obtuse triangle, okay? So that means not only is this scalene, but it's also obtuse. So it's a scalene obtuse triangle, or you could also say it's an obtuse scalene triangle, okay? On number 3 here, I do see that I have 2 sides that are congruent. If 2 sides are congruent, it means it's isosceles. And I will tell you that all of these angles in this triangle are acute. Since they are acute, classifying it by its angles, this would be acute. So again, this is an isosceles acute triangle, or you could say it the other way around, say acute isosceles. Okay. Going to number 4, it's a little bit different. So here in number 4 is where you're going to use the distance formula that we reviewed the other day. This is also where I'm going to use Desmos to help me out a little bit. Now, in order to determine what type of triangle it is by its sides, you need to know the length of each side. Okay, so in any triangle, there are 3 sides. So we have a triangle that's made up of these 3 points, and I'm not drawing this to scale. Just imagine that you have A, B, C. So that means in order to do this problem, you need to find the distance between points A, B, the distance between points B, C, and the distance between points C and A. By doing this, you're then going to be able to tell whether it's scalene, equal, lateral, or possibly isosceles. And again, my picture is not drawn to scale. Okay, so what you're going to have to do is you're going to have to use the distance formula. I will do the first one with you. Using the distance formula, like we talked about in class, for segment AB means I'm going to use these 2 points, A and B, as my x1, y1, and x2, y2. Okay, so for x2 minus x1, that's going to be 9 minus 6. No double negative there. Don't forget to square it. And then for y2 minus y1, that's going to be 3 minus 6. Don't forget to square it. So I have 9 minus 6, which is 3. 3 squared is going to give me a 9. Adding to that, we have 3 minus 6, which is negative 3. I'm going to square that, and I'm going to get a 9. 9 plus 9 is going to give me the square root of 18. Okay, you can go ahead and get the decimal, but I really don't need to find the decimal because I'm going to find the square root of all the others. So if the square roots match up, then you know that the lengths match up. So I know right now that this length is the square root of 18 or whatever decimal you would get using a calculator. So I'm going to go ahead and finish the rest of these. You're going to finish them on your own, and then we will come back and check our answers. So you should have noticed that all 3 of the lengths are different. So that means that this triangle is definitely scalene. Okay, now we need to determine whether it's a right triangle. Okay, so we're going to determine whether it's a right triangle or non-right. So we're not really going to go ahead and classify this by the angle. We're just going to determine whether it's a right triangle or not. Okay, so in order to do that, what I'm going to use is I'm going to use Desmos. So on your computer, there is also a phone app that you can use. I'm going to go to desmos.com. I'm going to click on Graphing Calculator. So on this, in order to create a triangle, you are going to hit a plus sign and click on the table. So we're going to create a table, and we're going to enter in the points. So the points were 6, 6. You just hit tab to go to the next one, 9, 3, and 2, 2. Now, if you want these to connect, click on these dots. Actually, click and hold. Okay, and it's going to ask you if you want lines. So you can see they're connected there. You can also change the color of your triangle if you wanted to. Okay. All right. So, and if you want to be able to drag the points around, you would click this, and it just allows you to move the points without typing in any new points. Okay. So you can see that it's not fully connected. In order to fully connect it, you have to type the first point again. So you'll see I typed that first point twice so that it connects fully. All right. So the one thing about this that you'll notice is that these are not labeled. If you want to see what the ordered pairs are of each point, just click on each of the points. So you can see that my triangle that I drew on the paper was not drawn to scale, right? So looking at this, I can kind of already determine that from point C, that right here at this angle where point C is, that's definitely not going to be a right angle, right? I can also tell, because this is drawn to scale, so you can kind of eyeball where you think a right angle might be to determine whether it's a right triangle. And remember, you only need one right angle to make a right triangle. I can also see here at point B, which is 0.93, that's definitely not a right angle either. This one up here is really close. I think it might be a right angle, but we want to double check. And the way that we can double check is by looking at the slopes. One thing we can do is we can calculate the slopes, or we can just use rise over run like we see here. Okay, so what I'm going to do is I'm going to find the slope of this line here, okay, which is AC, and I'm going to find the slope of this line here, which is AB. Our triangle there, we need to find the slope of, again, like I said, I'm going to have to switch back and forth of, what is this? 6, 6 is A, and this one is 2, 2. So I'm going to find the slope of line AC. So I'm going to find the slope of line AC, and I'll talk about why this works. And then I'm also going to find the slope of the other line, which is here, that creates that angle that I think might be a right angle. That's point A, and this is point B. So I'm also going to find the slope of AB. Now remember, the way that we count slope is we just count rise over run. That's all we need to do. So from one point to the next, we're just going to count rise over run. So we can see here, I'm going to zoom in so I can see all my numbers. If you want to get rid of all of these lines, if you click on this little wrench over here and you unclick minor grid lines, it takes away a lot of those grid lines, which makes this a little bit easier to read. So counting my slope from this point to this point. What I'm going to do is I'm going to count from this point to this point. That's going to be from, that's AC. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So your slope, you can see there, is going to be 1 over 1, which is just 1. All right, let's find the slope of the other line. The slope of the other line is going to go a rise of that's from here to here. So let me unclick this one. Looks like I'm going up 1 and left 1. So that means that I'm going up 1, left 1 gives me a -1, giving me a value of -1. Okay. So the way that we know that we have a right angle is if we have perpendicular lines. Perpendicular lines will have a opposite reciprocal slope. So not only will they be opposite signs, but they will also be a reciprocal. Okay, opposite reciprocal slopes. So 1 is, if you take the reciprocal of 1, you still get 1. Opposite of 1 would be -1. These are perpendicular lines, so this is definitely a right triangle. Okay, so definitely use Desmos to help you out with any of these activities that we give you to do. That graphing calculator is your friend. Okay, and if you ever want to use it and you're not sure how, please make sure to ask. All right, let's move on to a couple problems here. These are the last 2 problems, and we are going to go over the theorems here that we have left before we do that. Okay, so we have, again, don't worry about these theorem numbers. I'm going to cross those out, corollary numbers, cross that out. We just need to know that these things exist. An exterior angle theorem states that if you have a measure of an exterior angle is going to be equal to the sum of the measures of the 2 non-adjacent interior angles. So if we have the measure of angle 1, this is your exterior angle. Okay, non-adjacent means that it's the angles that are not next to that angle. So that means we don't want to include this one. That one is out. Angle C, that would be its adjacent angle, right? We want the non-adjacent angles. So we want this angle here, and we want this angle here. If you add these 2 angles together, they are going to equal the measure of this outside or exterior angle. Okay, so let's go ahead and use that. Sometimes when we use it, it just helps it to make a little bit more sense. So go to page 127 and let's look at number 5. On number 5, we have an exterior angle. They want us to find the measure of that exterior angle. So to find the measure of angle 1, which is our exterior angle, we're going to take the measure of the non-adjacent angles, which happen to be this angle here and this angle here, and we're going to add them together because that exterior angle is going to equal the sum of those 2 non-adjacent angles. So all I have to do is add 53 plus 53, and I get 106 degrees. So that is the measure of that outside exterior angle. In number 6, it's a little bit different because we have mathematical expressions in place of our angle measurements, but we can still use the theorem. This is our exterior angle, and our exterior angle is 8x minus 5 degrees. You can write it without the parentheses. And then on the, that's going to be equal to the sum of the two non-adjacent angles. So you don't want this angle right here. That's the adjacent angle, okay? You want the angles that are I like to think of it as opposite, right? They're a little bit opposite, but they're not next to it. So it's this one and this one. So what you're going to do is you're going to add those together. It's going to be 5x plus 15 plus 40. And now we have an equation that we can solve for x. So let's go ahead and solve for x because we can't find the measure of the exterior angle like it's asking unless we know the value of x. So we're going to go ahead and solve for x by combining like terms on each side. Then I'm going to subtract 5x on each side to cancel this out. And then I'm going to add 5 on each side to cancel this out, leaving me with 3x equals 60. Dividing both sides by 3, I get x equals 20. This is not your final answer. They've asked you to find the measure of the exterior angle. So now what you have to do is you have to take that 8x minus 5, and you have to plug 20 in. You're welcome to use a calculator at this portion of the problem to make the math go a little bit quicker, but you can see the math is not too challenging, and I get an answer of 155 degrees for the angle, the exterior angle's measurement, okay? We are not going to do number 7, but I am going to mention one more thing before I let you guys go. It's the corollary to the triangle sum theorem. And a corollary is just something that we know based off of another theorem. So because we know that all angles in a triangle, or the triangle sum is that they add up to 180, right? The angles in a triangle. We can then state that if we have a right triangle, meaning that this angle here, or one of the angles, is 90 degrees, that means that the other two angles have to add to 90. So if I know angle C is 90 degrees, then I know that the other two angles, A and B, would have to be 90 degrees. Okay, we didn't use that in any of the examples today, but that's definitely something that is nice to know. Okay, so I hope that this was helpful and also informative. If you need help, please come to support, and best of luck with your practice.